Okay, so we got a question right here. At that time, one model for the structure of atoms was the plum pudding model proposed by J.J. Thomson. In this model, the positive charge and mass were spread evenly throughout the atom. Negative charged electrons were distributed within the atom. Discuss the extent to which the results of alpha particle scattering experiment justifies replacing the plum pudding model with a nuclear model of atom. So we have two main important points that we have to contradict, right? So the first point is basically the J.J. Thomson's model, the plum pudding model, states that the positive charge and the mass were spread evenly throughout the atom, and negative charge electrons were distributed within the atom. So these are the 2 points that we have to contradict, right? So as we know how the alpha particle experiment works, right? So basically one when the alpha particles were basically, I'm going to write the point and I'm going to write the sentence for you guys, okay, for to have the idea of how to write a structured proper sentence, right? So basically alpha particles, the first thing that the experiment told us, that when alpha particles were basically released, right, this were released, right, it went straight through the gold foil model, right, gold foil, right, and then it was detected through detector, right. So he concluded from this basically experiment, from this first incident, that most of the atom was empty, right. And the second thing was only like very few, like you can say half, less than half of the particles, alpha particles, you know, were deflected, like it went this direction right here, right, it went back at an angle of less than 10 degree, right. You can say, no, not this direction, maybe like this direction, angle of 10 degree, right. It just deflected at 10 degree from the gold foil, right. This is gold foil, right. So he concluded from this action that there is a positively charged particle, positively strong, you can say strong positively charged particle, right. He didn't knew what was the particle, but he knew that it was a strong charged particle, because alpha particles basically contains, alpha particle contains basically two protons, right. But the now we have to contradict these points, right. Two protons mean it needs like a strong charge to basically like repel it, like go over here or maybe go over here, right, basically repelling it, right, and not going from this to the straight direction. It basically doesn't go to the straight direction, right. So but the plum model says that the deflection or the most of the atom shouldn't be that empty, because as we know that it is spread out evenly, the charges and the mass, right. The plum model says, like basically the plum model says that it is spread evenly, right, spread evenly basically. But it doesn't, as we can see from this experiment, it doesn't support it, it doesn't support it at all. Now we have basically the third point that he concluded, that very few particles were deflected back, right. It went here and then it came back, above 90-degree angle. It deflected backwards, right. So it was above 90-degree angle, right, from the gold foil basically, right. So he concluded from this that there is a concentrated, this is a main word, concentrated, you know, basically concentrated mass of the particle, which we know as nucleus, right? Nucleus at the center, basically at the center of the atom, right? But we know from the Plum model that they are spread evenly, right? So it also doesn't support this conclusion, right? The Plum model says the same thing, but it doesn't basically support this theory that was concluded from the experiment, right? So that's why we can basically say that this did not fit the Plum model, as this deflection requires higher concentrated mass, right? And this did not was proven in the Plum model, right? So let me basically write the proper sentence for you. I have explained you in these points, and I'm gonna write the sentence for you out. So I have written the sentence: most alpha particles went straight through the gold foil, stating that most of the atom was empty, right? As we have discussed before. Some of the alpha particles were deflected by small angles which were less than 10 degree, stating that it had a strong positively charged particle. But now we're gonna contradict the sentence that was given to us. But as we know, in Plum-Pudding model, positive charge and mass were spread out evenly, right? Now it's not supporting the theory given by the Plum modeling, because it's contradicting the experiment that was done by the scientists to figure once they did this experiment of the alpha particle, right? So very few alpha particles were deflected by more than 90-degree, right? It were deflected largely, like they went like backwards, they went like up, they did not went straight, right? They were very few, right? This did not fit the Plum pudding model, as this deflection requires a high concentration to basically make it go back. It requires high concentrated of charge, because alpha particles has 2 protons, right? So it must have like equal to 2 proton, or maybe greater than 2 proton, like, so it must have high concentrated of charge to provide a large force. This could only be explained by nuclear model. This is the experiment of alpha particle, right? As this deflection requires a higher concentration of mass. So this is our answer.